Hey everyone, welcome back to another video in this series. So, in the last video, we had our AI moving along a spline as a patrol route, but as you can see, it doesn't actually react to the player at all. So, in this video, we're going to make the AI able to see us and respond to that. We'll do this using AI perception. First thing, we add it to the AI controller, not the AI character. That's important. Then we add a new sense, and as you can see, there are a bunch of options, but for now, we'll start with vision. So we select AI Sense, SISI, Sight. After that, we'll tweak the settings here, mainly the sight radius and lose sight radius. I'll use the values I prefer, but you can set whatever works for your game. Let's do a quick test to make sure the AI perception works. And yeah, it's working fine. And if you're wondering how I use that AI debug tool you just saw, it's pretty much the same in every engine version. If it doesn't open for you or you want to change the shortcut key, just go into Project Settings, Gameplay Debugger, and set the activation key however you like. I personally leave it at the default. Cool. So back to where we were. The perception system works. I'll just change the vision angle to 85 degrees, and now let's move on to the next step. Inside AI perception, we scroll down to key on target perception updated. Here we get two variables. These are what we'll work with. So let's create a new function called *a I underscore perception underscore sight asterisk. We give it the two inputs, actor and AI sense stimulus, and we connect it to the on target perception updated event. Inside this function, we grab get sense class from the stimulus and check if it's AI sense sight. Then we break the stimulus, and before continuing, we'll create a new variable called cPlayer. What we want here is, first, check if the AI actually detected an actor. Then, check if that actor is the player. If yes, it sees the player. If not, it doesn't. Okay, let's test quickly to see if the AI detects the player. Yep, working fine. Now, let's build some basic chasing logic. We want the AI to follow the player when it sees them and stop when it doesn't. For now, we'll keep it simple and expand later. So, first, we make a custom event called chasing player logic. Inside it, we check if the player is seen. Before we continue, we'll also create another custom event called goToPlayer, and we connect that with the player scene logic. Then, another custom event called stopChasingPlayerLogic, which we connect with the player_not_seen logic. Basically, chasing player logic decides when to start and stop chasing. GoToPlayer handles what happens when chasing starts. Stop chasing player logic handles what happens when chasing stops. Now, let's set up the go to player event. We only want it to run once at the start. When it runs, the AI should move toward the player immediately. If it fails to reach the player, it should retry every zero point 0.2 seconds. But before retrying, we make sure the AI is still chasing the player. To do that, we create a variable called isChasingPlayer, set it to true when chasing starts, and always check it before retrying. Before we continue, let's grab the character movement component from the AI character using getComponent by class and store it as a variable. We need it because when the AI starts chasing the player, we want it to run faster. And when it stops, go back to normal speed. I'll set the chase speed to 450, but we'll keep it as a variable so we can tweak it later. Also, when chasing begins, we want any idle or stop animations to end, but not instantly. It's more realistic if there's a tiny delay before reacting. So, we add a short delay before starting the chase. Now, let's set up the stop logic. When the AI stops seeing the player, we want it to 1. Stop chasing. 2. Lower its speed back to normal. 3. Execute this logic only once. 4. Most importantly, return to its patrol path. For that, we'll make a new function called back to previous path. It's basically copied from the patrol logic we built earlier, but we'll reuse it here whenever chasing ends. If we test this now, we'll notice the AI only runs the logic once. That's because we use do once at the start of each logic block, so we need to reset it at the end of each chase. Alright, let's test again. Yeah, the AI still doesn't follow the player, and I know why. It's because we haven't called the chase logic from event tick yet. So let's add that, and now it does chase the player. Okay, but we still have some issues. First, let's double check everything works. Let's expand the nav mesh bounds a bit so the AI can actually follow us properly. Still some problems. I think I know the fix. It's an old mistake I've made before. We'll just copy this part of the logic, delete it, and re-add it directly after we cast to the character. That should fix it. Yep, that fixed the error. But there's another issue. The AI doesn't go back to its previous path after stopping. And the reason is I set the path number variable before subtracting one, which broke the logic. After fixing that, I'll also add a missing branch check to see if the AI is chasing the player or not. Now everything should work fine. And yeah, it works. One more small adjustment we will add. After the wait time ends, if the AI is still chasing the player, I don't want it to just continue to the next blind point. Instead, it should keep chasing the player. To fix that, we'll add a simple check right here. Final test. Yep, now everything works as expected. The AI returns to its patrol when it doesn't see the player, and whenever it sees the player again, it goes right back into chase mode. Good. Now that we've finished the hardest part, we're going to improve the AI's logic for stopping the chase. We want the AI to check for 3 conditions before it stops chasing the player. First condition, which we already achieved, the AI must actually be chasing the player. Second condition, the the player must be out of sight for at least 3 seconds. Third condition, the player must be a certain distance away. We already handled the first one, so now let's work on the second, making sure the AI loses sight of the player for 3 seconds before deciding to stop the chase. First, we'll create a float variable called cAge. Then we'll create a custom event called LastTimeCPlayer. Inside it, we'll add a simple check. If the AI sees the player and is currently chasing, then we'll update the cAge variable. We'll use a node called FInterp2Constant for this update. The target will be 0. For delta time, we'll use getWorldDeltaSeconds. And for interp speed, we'll set it to 0.4. We'll change the condition logic slightly for better accuracy. The cAge variable will only update while the AI sees the player and is chasing. If the AI doesn't see the player at all, then we reset cAge to its default value. I prefer setting it to 3, which represents roughly 3 seconds. We make sure this event is connected to event tick so it keeps updating. Now, in the stopping logic, we'll add a condition that cAge must be equal to 0 before the AI stops chasing the player. Let's test it quickly as usual. And yes, it works as intended. When the AI sees the player, the value stays at 3. When the player goes out of sight, the value starts decreasing gradually back to 0. Once it reaches 0 and the player is still not visible, the AI stops chasing. But if the AI sees the player again, boom, the value resets to 3 and starts counting down again, exactly as we want. Now, let's move to the final condition, the distance check, which is the easiest one. To implement this, we'll create a function to calculate the distance between the AI and the player. We simply use the node getDistance to between the AI and the player, connect it to the return node, and make this function pure. Next, we'll create a custom event called checkDistance. Inside it, we'll check if the player is far enough from the AI using our distance function. For the threshold, the most logical choice is the lose sight radius from AIPerception. After that, we'll create a new variable called playerIsClose. We won't use it yet, but it will be useful later to know if the player is within the AI's full perception range, front or back. Now, inside the same distance check, we'll add a condition. The player must be at least 450 units away before the AI stops chasing, because it wouldn't make sense for the AI to stop chasing if the player is still very close, especially if the AI just saw the player hiding before losing sight. That's why we added this last condition. So let's run our regular check to see if everything works. Perfect. Everything works without issues. Alright, I think that's enough for this video. In the next one, we'll continue making the AI senses more realistic and smoother, since what we have now is still a basic system. In the upcoming video, we'll work on 2 important things. Making the AI start chasing the player if the player touches it. Now this is really important because if the player is hiding in tall grass, the AI should only discover them either when touched or when the player stops crouching. Making the AI detect the player if they are behind it, and also checking if the player is crouching or not. It's also possible that I'll make a separate video about preparing the player system for crouching and health before we start the next part. So yeah, that's it for now. See you in the next video of this series.